WebRTC is an exciting emerging standard that's changing communications over the web. It allows users to conduct secure, real-time communication using a standard web browser and staple web technologies like HTML and JavaScript, all without the need for additional client install or plugin. Imagine being able to voice or video chat with anyone simply by accessing a web page. The Fusion Client SDK extends the power of WebRTC into the enterprise and telco network, providing a way to apply existing routing and feature sequencing to calls originating from or terminating on the web, allowing you to build communications directly into any website or mobile client. It also adds the ability to embed increasingly important features like instant messaging and presence, as well as leveraging voice and video communication. Now, it's not just about connecting Alice to Bob so they can talk to one another. It's about doing it in a way that leverages Alice and Bob's known endpoints and registered devices, using their existing application sequencing profiles and their unified enterprise dial plan. In other words, the SDK allows you to write applications that plug into your existing communication network and provides seamless access to the apps, services and routing already set up in that network. Now, the SDK is divided into three complementary sections. The Fusion Client Core SDK provides the JavaScript libraries necessary to build these client web applications. It also delivers the server-side components deployed in the enterprise that clients will need to communicate with in order to establish calls. The Fusion Client iOS SDK and Fusion Client Android SDK both provide the platform-specific libraries that enable you to build rich native apps that tie into the enterprise communication systems. Clients built with these native SDKs will communicate with the network services provided by the Core SDK. In this video, we'll give a basic overview of the Fusion Client Core SDK. By the time we're done, you should have a good basic idea of how it works and how it ties in with WebRTC and an enterprise's existing infrastructure. The Fusion Client SDK builds on WebRTC and allows users to register web clients as though they were endpoints in the native enterprise network, to make calls and receive calls with other similarly registered endpoints, whether in the enterprise or on the web. It works hand in hand with what's already in place, adding to and leveraging existing telephony services. The beauty of a browser-based client is that you can have it anywhere you have access to the net, on your tablet, laptop, or even on your smartphone. Browser adoption and support for WebRTC is already strong and is steadily growing toward ubiquity. The Fusion Core SDK is a combination of JavaScript API and supporting network services with which it communicates. In concert with the Core SDK services, the API enables developers to create regular WebRTC web applications that interwork seamlessly with the existing enterprise or telco network. Let's consider the different components. We'll start with the WebRTC-enabled internet browser. There are two important scenarios to consider, the first being a call between two browser-based clients, and the second where either caller or callee are inside the enterprise network. Imagine me in a B2C business-to-customer scenario where I'm surfing the web, see something I like, but want to discuss it, so I click to talk. Simply clicking the URL downloads application JavaScript to my browser and creates a relationship with the web gateway. It then calls out over SIP to set up the call. Simple. Now, it might be that I'm an enterprise user away from the office today, but keen not just to make calls, but make and receive calls direct to and from my browser. Again, I click an application URL to download the application to my browser. This time, the JavaScript not only sets up a session with the web gateway, but on my behalf performs a SIP registration with the enterprise SIP registrar. Then, when someone wants to call, my registered details cause the SIP request to be routed to the web gateway, which in turn calls out to my browser over WebRTC, and the call is established. The web gateway translates between WebRTC and SIP, converting instructions received from the browser to the equivalent SIP expected in the enterprise, and SIP from the enterprise back to WebRTC to the browser. Perhaps I want to call a colleague who's also using a WebRTC client. By clicking a link or dialing the extension, the web client sends an offer to the Fusion Web Gateway. The offer is received by the gateway and its intent is translated to the appropriate SIP, which then gets passed downstream into the internal network. It's here in the enterprise network where CAC, or call admissions control, can be applied, as well as routing policies, application sequencing, mobility, conferencing, or any of the other rich services available. With the appropriate enterprise call processing complete, and so long as my colleague's registered through his web client, the invite gets routed to the web gateway, where the WebRTC HTTP signaling is managed to set up the call. Messages are passed back and forth between the enterprise network and the caller and callee, mediated by the web gateway. Once the call is answered and the appropriate messages have been sent, both WebRTC and SIP, then the RTP sessions established between the two endpoints. So what happens if we want to call someone registered with a traditional endpoint inside the enterprise? Well, the Fusion Client Core SDK has got you covered. The signaling is very similar to the previous scenario, except the location service knows the endpoints internal to the enterprise network, perhaps registered with a standard registrar server or hanging off an IPPBX, so routes the call accordingly. Although the signaling is straightforward, the RTP, or media exchange, could prove problematic. WebRTC clients and SIP clients might not share the same media capabilities. WebRTC applications typically use the web standard VP8 video encoder, whilst most enterprise video devices use H.264. Without help, they just can't exchange video unless something somewhere performs media transcoding. That's the job of Media Broker. It takes VP8 media streams on one side and transcodes them to H.264 streams on the other, and vice versa. Media Broker enables users to share secure video calls from a whole range of devices and to join conferences from almost any endpoint. Media Broker also maximizes video stream quality. It monitors the network bandwidth and, when there's congestion, dynamically decreases bit rates, avoiding packet loss and jitter. It also monitors packet loss, requesting retransmission of any lost packets, inserting them back into their correct sequence. It's amazing the difference lost packet replacement makes to call quality. Okay, let's see how simple it is to set up a call. I've already browsed the sample Core SDK application in two browsers here on my desktop. I'll log in with the first, knowing the application will register me with the Enterprise SIP registrar, and again with the second, meaning the two browsers can both make and receive calls. Even though it's a sample app that demonstrates what can be built with Core SDK's JavaScript library, it is a fully functional voice and video client. So now if I dial from my first browser over to the second, the call comes through and the call's established. Simple as that. A call between two browsers with no special plugin or download. Okay, that's about it for this introduction overview. You should understand the nature of the Fusion Client Core SDK, including its benefits, components and interactions, and how it translates between SIP and WebRTC, giving access to full enterprise calling and enterprise features over the internet from a regular browser.